All right. Good evening, everybody on the call, and thank you all for joining. So today we'll have a webinar session. My name is Namdi Omagina, and I'm the moderator for this session. So good evening once again, everybody, and just to welcome you to the presentation today. It's my pleasure to welcome all of you to this special session organized by the AMPP Lagos Nigeria Chapter in commemoration of the World Corrosion Awareness Day. Your presence here today reflects a shared commitment to advance knowledge, collaborate, and best practices in corrosion prevention and material integrity. So today is April the 24th, and April the 24th, it's annually celebrated as the World Corrosion Awareness Day, and it highlights the global impacts of corrosion on infrastructure, safety, the environment, and economies around the world. Corrosion is critical to the integrity. Corrosion management is critical to the integrity of, assets, and it's a big challenge across industries. So particularly in the oil and gas, marine, energy sectors, and you name them, the list goes on and on. So effective management is essential to asset integrity and sustainability. So this day would serve as a platform to raise awareness and share knowledge and promote innovative solutions in corrosion control. So a brief overview of the Lagos AMPP Lagos Nigeria Chapter, where I currently am the Vice Chairman. It's a part of the Global Association for Material Protection and Performance, dedicated to advancing the science and practice of corrosion control and protective coating. So the chapter actively promotes professional development, knowledge sharing, and industry collaboration through technical sessions, webinars like this, training programs, and student initiative engagement across Nigeria. Yeah. So brief housekeeping rules and guidelines. The session will consist of a technical presentation delivered by our speaker, who is already on the call, and followed by a question and answer segment. So participants are encouraged to take note of their questions during the presentation and share them during the question and answer session. So you can drop your comments or questions in the chat box, and in the end of the program, they will be attended to. So just also to inform us that this session is recorded for documentation and knowledge sharing purposes. So we seek your consent to record, and this may be shared with the AMPP community for future references. So on that note, we'll play a brief video that will discuss the citation of the speaker today, and we'll go on with the presentation.
Keita is a coatings and asset integrity professional with expertise in corrosion control, protective coatings, and maintenance solutions for critical assets across industrial sectors. She currently works with Navante Oil and Gas, the authorized distributor of Belzona in Nigeria, where she delivers innovative repair and protection solutions for onshore and offshore operations. With a strong background in technical sales, project management, and field-driven problem solving, Nonye is passionate about bridging the gap between coating specification and real-world performance. Her professional focus spans coating selection, application best practices, composite repair materials, and coating inspection. A 2025 AMPP Global Ambassador and advocate for knowledge sharing, she is committed to advancing industry best practices and inspiring the next generation of professionals in corrosion and materials protection. Today, she will be speaking on protective coatings, selection, application, and failure mechanisms. The session will highlight how proper coating selection and application influence asset performance, as well as common failure mechanisms and how they can be identified and prevented to ensure long-term corrosion protection. Nonye, you have the floor. Thank you.
Yeah, all right. Thank you so very much for that very brief introduction. Excited to be here with you all this wonderful evening. Hope we are doing well in our various locations. So I officially welcome you to today's webinar session, starting this year's World Corrosion Awareness Day. Today, I'll be taking the topic protective coatings, selection, application, and failure mechanisms. So I would like us to engage as much as we can. Feel free to ask your questions. Feel free to share your suggestions or opinion on the topic. But I know it's something that we all would like to know. We know very well in this country that we have a very common issue, especially for us in the coating space. We've seen often that our coatings sometimes fails unexpectedly. Sometimes you may wonder what went wrong. In fact, I noticed something that we also like the blame game, where could the problem be coming from. Sometimes we say the manufacturer didn't do well. Sometimes we say the contractor is inexperienced. Sometimes we can even say, oh, okay, the substrate is not good and all of that. But in today's session, we'll be learning what we are getting wrong, where we've been doing it wrong, and how we can actually get better. So just walk with me. Yeah, the introduction has already been made. I don't think we need to repeat the session. The critical role of protective coating in asset integrity. So that's the baseline of our conversation this evening. So I'm asking, and did you know that most coating failures are not caused by the coating itself, but by how it was selected, prepared, or applied? So that is one fact I want to establish from this conversation, that a coating fail does not necessarily mean the coating is bad or it was not properly manufactured or produced, but it is how do I put it, a decision from what we do, how we select the product, how we prepare the substrate, and how the products are applied. Protective coatings are engineered systems, not just paints. I've had a lot of arguments about what is paint, what is coating, what are the differences. Paint is paint. In fact, even professionals in the industry we still hear a lot of people talk about when it comes to asset integrity. You know very well that it is not just paint, it is protective coatings, because we are trying to do what? We're trying to mitigate corrosion. We're trying to protect our substrates from corroding and deterioration that can come from the corrosive environment. So protective coatings are an engineered system, not just surface finishes, meaning there are a lot of intentional efforts that are put into formulations to be able to ensure that the product meets requirements by the substrate and the environment it is going to perform in. They act as the barrier as the primary barrier between assets and corrosive environment. So, you know, when we talk about trying to protect our systems, our assets, whichever one in different facilities, what we are trying to do is to prevent or to protect that substrate, to protect that asset from reacting with the environment that will cause it to degrade. So one of the common ways to actually protect this substrate is by the use of protective coatings. So they act as this primary barrier between the assets and the environment where they are placed in and the condition at which they are working. Their performance directly affects asset lifespan, operational reliability, safety, and environmental exposure. So when coatings fail, the asset is no longer protected and deterioration accelerates. So this is one of the reasons why we really want to protect what we value. We really want to protect where our money is coming from. So always have it in mind that the moment you're compromising on the coatings that is protecting this asset, you're already trading with destruction. You're already trading with loss, safety issues, and all of the problems that comes with degrading assets. So cotton selection, this is where it starts going wrong. I've heard a lot of people, please just give me, in fact, I noticed that in this part of the world, we are very careful with costs. We try to manage when it comes to when it comes to design, material selection, when it comes to protecting that system, that is when we know we are going above budget. So cutting selection is often where most people still get it wrong today, and these are some of the ways. Cotton selected based on costs and not on the conditions of the substrate. This is very common. A lot of people, in fact, they can do everything, and when it gets to the time for coating the system, that is when they'll start asking, are there no alternatives? Can't you in fact, some will even tell you, let's just coat it so that it will look neat for the GM or the owner of the asset to know that we are working. And some will even tell you intentionally that, see, if we coat it in a way that it will last or it will stand the test of time, we won't get jobs. So the cheaper the product, the more the opportunity for us to repeat this job. But if we look at it in the recent, are these really economical? Is it really safe? We do a lot of compromise because we're trying to cut costs. We're trying to, as far as I'm concerned, we're just being if we do that, we're just being foolish in the real sense, because at the end of the day, you spend more than you think you're actually spending. Then misalignment with service environment. That is also very common. A lot of people request for coatings, go to the market, open market, just buy coating materials without even trying to consider the environment they are trying to put that coating product in. Then ignoring chemical, temperature, abrasion exposure. So like I said earlier, protective coatings are engineered system. So it means a lot of factors are usually put in place to ensure that the formulation actually matches or meets the requirements. There's what's the system we go through. So if you're not putting if you're not putting the chemical, the environmental temperature, and all other factors that this system is going to go through, if you're not putting it in place, you're not considering that before getting your coating, it shows that you're already preparing for failure even before the main failure. And another thing, no life cycle thinking. We just want to paint for painting's sake, like what a lot of people do. So as professionals, I'll always advise and I implore us to be very intentional, more conscious when selecting our coatings. You don't just go to the market and get epoxy coatings because they said epoxy is anti-corrosion. No, there is more to it. Try to find out the epoxy you want to get, does it really fit the environment? Talk about the ultraviolet radiation on that environment. Is it something that will be exposed outside? Just like an example I gave here, using atmospheric coatings in immersion. Imagine a product that is supposed to that is supposed to perform well in the open, and you're putting it in a splash zone area, or using an acid-based coating in an aggressive environment and expecting it to perform. Sincerely, it will fail even before you expect it. So always know that a coating that works in one environment can fail rapidly in another. So it is not just about the coatings, it's not just about what you buy, it is about the decision you have made while trying to coat that system. So Let's be more intentional. Then matching coating resins system to service condition. Like the basic of every coating today is the resin, and the resin actually is the binder. It's actually what tells us how that coating will perform. That is the major chemistry behind every coating product. Any coating at all, you may want to ask what resin system is it, so that it helps you know how the coating will behave in certain environments. Like for atmospheric exposure, you want to use an epoxy based, probably as a primer or intermediate coat, and a PU. And why are we using a PU? And that's because epoxies are mostly susceptible to choking. They are not friendly with sun. They are not friendly with environmental what's it called, UV rays. So if you want your epoxy to perform well in an open space or in an atmospheric pressure, you need to top coat with a polyurethane based product. And that's why does it work? Because it gives corrosion protection plus UV resistance. Then immersion, like you have a system that is submerged in water. What kind of coating would you use? An epoxy and a glass flake epoxy. And the reason is because they have very low permeability and they have good barrier protection, excuse me. Then chemical exposure, you want to use Novalac epoxy because of their high chemical resistance. Then fast forward to abrasion or erosion, for instance. You can't just say, oh, because a lot of people say polyurethanes are flexible, okay, that means it can withstand abrasion. Yes, that's true, but to an extent, the engineered system of a protective coating may require you to use a product that is ceramic filled. You know how ceramic behaves, is able to withstand high abrasive environment and erosion. So, and that's why it does that, because it has very excellent wear resistance. So all of these are the things you actually need to think about, consider before making your coating selection. No coating system performs optimally in all environments, no matter how good or innovative it is. Just know that every innovation has also come to solve a particular problem. So find out. It's not just about, oh, that product is very good. The manufacturers are up to date. Also find out that innovation, what has it come to solve in the asset integrity world. You need to be very intentional, and that's what makes us professionals that we are. So moving on to the next slide, we have surface preparation. This one cannot even be overemphasized. And I think that is where we have the largest failure rates attributed to. So some of the common mistakes that happens why on this is that we are likely to see inadequate blasting. So as coating inspectors, in fact, if you're on the field, you see a lot of this happening, and sometimes you see contractor giving you one reason or the other why the system cannot be blasted further. Some will even tell you, we did this. Some, in fact, this time around, you see a lot of terms. You hear a lot of terms, and you'll be wondering, where did this one come from? Like, is this an SSPC standard, or where? What did you develop this standard from? That makes you feel that with this current level of cleanliness that you have on that substrate, it can actually hold the incoming coating and it will stand the test of time. So we need to be very, very careful and be able to stand on our ground in certain situations. Okay, so residual contaminants. This is very common too, part of the cleanliness problem we normally have on substrates. Then incorrect surface profile. Yes, you see a lot of blasting going on. You see a lot of surface preparation. Know that when you don't have the correct surface profile for the system, for the coating that is about to go on top of the system, you're likely not to get the adhesion that is needed for that coating. Then rush or skip preparation, many, as long as you're not on site as a coating inspector. Contractor, some will even paint on a rusted steel and they will tell you, the next thing you hear is, I'm done, the job is over, everything. Of course, when you go to site, you see it looking good. but just give it time. You start seeing issues like rust bleed. Why? Because the preparation was not properly done. So what must be done right? Degreasing and cleaning. That is very important. Abrasive blasting has been proven to be one of the most efficient way of cleaning our substrates. So if the specification states, okay, do SA 2.5, if it says do SA 3, you have to follow what the specification is saying and be able to do your cleanliness to that level that the coating requires. Also, achieving correct surface profile, we've talked about that. Then removing salts and contaminants. If these things are not done properly, you're likely to have failures. Like I said, our decisions from the onset actually determines whether or not our coating will perform or not. So the decision you make actually starts the failure or the win. So you have to be careful why making this. It's actually more of a human thing than even the system. So if we decide we want to select our coatings right, we decide we want to make our surface preparation as good as it should be. It means that yes, we are already preparing for success. But when we want to compromise at the planning stage, just know that you're also compromising the result of that coatings. And like I said in the earlier slides, when your coating fails, you just increase the rate of deterioration of that system. So coatings don't are there to steal, they are there to preparation. Moving next to application side. So we've talked about selection, we've talked about surface preparation. Now let's talk about application. The same coatings that has gone through proper selection has also gone through good preparation before it is applied on that surface. The next thing is on application. Now, I know there are lots of techniques that should be put in place when applying products, and it requires people that are skilled, people that knows what is required. So application techniques, setting your spray gun, the pressure and all of that. Then film thickness, a lot of people don't even care. What they know is do one pass, do two pass. So you need to be sure that you're getting the required welt film thickness that will give you the specified DFT at the end of the day. Then missing ratio, very, very important. Then port life and curing time. All of these information are usually embedded or given on the specification data sheets or product data sheets or technical data sheet, as the case may be, depending on what the company calls it. So all of these are very important while you're preparing your coatings to actually do well on your substrate, to actually protect your substrate. And as you're doing this, you also need to check for quality and be sure that you are conforming to what is expected. Then the next slide is environmental condition. This is the part that most people often overlook. You're just ready to coat. Like you're not even wondering if the environment is suitable for that product you want to, if the environmental condition, I mean to say, is suitable for that product you want to apply. The temperature, as a rule of thumb, we know that surface temperature must be at least 3 degrees above dew point. 3 degrees above dew point. Do we really check? Or we just, sometimes you see some people, they will tell you, okay, we can do this job at midnight before the asset owner comes. So as much as you want to see your job done fast, as much as you want to meet up to deadlines, please, you have to be very, very careful, because these assets are very critical and important, especially in the oil and gas environment. In fact, every environment actually, because we have steels performing different function in different industries. Then the humidity, as a rule of thumb, relative humidity must be less than or equal to 85%. Then dew point control too. Avoid coating during rain. So you also have to ensure that you are parties with your technical data sheet. You need that document to see. I've seen a lot of people who buy products, and even when you give them the technical data sheet, they don't know what to do with it. And I want to believe that as professionals, that should not be seen within us. You have to ensure that your technical data sheet is as important as your notepad, is as important as your logbook. You understand? So you have to be sure that you're working with within specification limits and what the technical data sheet is saying to guide you on how to go about application of this product. Virtually all technical data sheet I've seen actually gives information about the level of surface cleanliness required. It tells you what's, even to the extent of settings of your spray gun. It tells you the kind of environmental condition or temperature that the coating should be applied. So let's always do it. That is one arc a lot of us actually miss. If you don't know how to go to about it, if you're not sure, consult the manufacturer's data sheet. Apply within manufacturer's recommended temperature. I already said that. Then wind or dust control is critical in an open environment. I notice a lot of us also ignore this part. So if you are coating in an open space with high wind speed or the likes, you may need to control the environment in such a way that it doesn't give you a bad spray result, or even bring back the dirt that you've wiped off on your screen back to the surface. So this now takes us to quality checks. So these steps are important to confirm all parameters are within specs. It aligns with coating manufacturer's data sheet and conforms to standards and best practices. It is important to check the following after application. So we've talked about what protective coating is. We talked about the selection and how we should be intentional about it. We've talked about surface preparation and the quality checks that should go into our surface preparation, quality assurance, and worked on to confirm. You check anywhere that you start having corrosion from. You need to do all of that. Then addition test too. We all know that addition test is actually destructive, and I normally advise you should always have a sample panel to do all of this off field before getting to the field, or before doing that same test or carrying out that same checks on the system you have quoted, except the asset owners authorize you to do so. You understand? You don't want to destroy a 3,000 meter cube tank because you want to prove that what you have inspected or what you have quoted is right, except the asset owner tells you, okay, go ahead. And of course, they would have signed or let you know, no problem. I want you to just carry out the addition test on the substrate and let me know. I'll bear the cost of whatever it will take to repair it. So once you've done that, you document rightly, you're sure that you can actually report the exact condition of the substrate that has received coating. And it also helps you apart from documentation, when there's a failure, you know what to reference, and you are able to trace where these failures comes from. Good coating fail when application conditions are ignored. That is just the truth. If you don't do all of these things, no matter how good the coating is, it's likely to perform below expectation. Then failure mechanisms and root cause. So we see a lot. These are few of what we see almost every time on the field. So you may have blistering. This is actually very common, very, very common. And what are the causes? Moisture ingress, salt contamination from that system. Then peeling. That one is just quite obvious. Poor adhesion. And sometimes when you apply a coat without a primer for a product that requires you to prime before you apply the product. If you don't prime, you're likely to get peeling. You're likely to get the paint to peel. And if you don't get the right surface profile, because surface profile gives you the anchor, provides the anchor for this product to adhere on top upon. So if there is no proper surface preparation, you don't have the right primer beneath the top coat, is likely not to stay. It is actually very common. So then cracking, which comes from excessive thickness. Then rust bleed. In fact, that's actually the result. You see a very beautiful coating that you think, oh, this is very nice, very clean, everything looking smooth and shiny, and you start seeing dots here and there with rusts from those portion. That is as a result of an area that's been skipped while coating is ongoing. So that's a result of all the days of pinholes. Then blushing. Blushing, amine blush, actually for epoxy based coatings, comes up mostly when you're coating under moisture or a high humidity environment during drying. So you want to cure a product that is not supposed to cure under moisture. You want to cure it while the relative humidity is high. You definitely get those skin blushing. Those blushing are all those things you see. You start seeing a lot of shades on a product, on a surface that has been coated. Then orange peel, that is also as a result of poor spraying technique. So if you look at everything here, you see that it cuts across application problems to surface preparation problems and also product selection problems. Then coating failure is not inevitable, it is preventable. The fact that we see coating fail every now and then does not mean it's normal. It's just as a result of the decision we make while trying to protect our assets. So some coating failure examples, these are quite common. Like I want to believe at least 90% of us on this call would have seen some of these failures or coating defects on the field. So I just picked very few common ones. We see blistering, which is as a result of moisture or salt contamination. Delamination, you see rusting happening beneath a coating film. Chalking, which is mostly associated with paste coatings. Then pinholes, like we have here, orange peel as a result of poor spraying techniques, and fish hides too. These are quite common. It's just for me to let you know that yes, that they are common does not mean they should actually be happening. And on this kind of day for World Corrosion Awareness Day, is just for us to reinforce our knowledge and remind ourselves that yes, that they happen always does not mean it is impossible for them not to happen. So it's just a conscious effort we all have to put together as professionals in the industry to reduce the rate at which our coating fails. Then going to the next slide, breaking the cycle of coating failure. I think I've talked a lot about why coating fails. Now, how do we actually stop this from happening? Like I said, even though it's not on this slide, it starts from our own individual decision. It starts from our attitude. It starts from how do we really see these coatings? Is this supposed to be just for the sake of working and getting paid, or doing it as if, yes, we really have to make this protective coating protect what it is supposed to protect? So it all starts from our decision, from coating selection. It all starts from the conscious effort we put in while trying to ensure that our surfaces are clean. So select based on service condition. Like I said, no two coating performs the same way everywhere. That a coating works very well on this particular region or on this surface does not mean or does not guarantee that it will perform very well in another region. So select based on service condition of that system. Use correct resin systems. Just like I mentioned earlier, every service condition, every operational condition, every factors that goes into a system determines what kind of coating we best protect it. And those are the informations we need to get or be sure of before choosing what product works for different environment. Then enforce proper surface preparation. This is quite difficult, but I know it is doable. You have to ensure if the system requires you to clean to SA3, there shouldn't be any compromise. That's because for the specification writers or those that have put those informations together, they must have discovered that at this point, for this system to be able to spend the next or last the next 10 years, we need a white melter, not even near white. And every coating that will be applied on it requires that level of cleanliness to adhere properly. And like I always say, the success of every coating system starts from the adhesion, and adhesion is directly linked to surface preparation. So control application environment. These I've said that. Then inspect and verify. I say this always. It looks dry. It's not a term that we should use as coating inspectors or coating professionals. Oh, it looks clean. Mm-mm. It looks is not a confirmative, is not a confirmation word. Yes, we know that you're trying to be affirmative based on what you've seen. What test have you done to actually verify that that system is actually clean? What did you do that confirms that the the surface of the steel you want to coat is dry? What did you do? How did you do that? So inspect and verify. And that does not mean, yes, you can always inspect and verify, and maybe you're always getting values that are within specification range, but then until you carry out those tests, you cannot be too sure. So that it even helps you to trace where problem comes from, just in case there's a failure. It just puts you on check. It doesn't throw you off balance. It doesn't put you under confusion when a report comes and say, okay, something did not go well or something has gone wrong. It helps you to trace where the problem is likely to come from, because you checked, you inspected, you verified, and you documented for future references. Then think life cycle. If you want your product or you want a particular system to remain in a splash zone environment for the next 5 years, you know what to do. Ensure that you're picking the right coating choice to ensure that that product will serve well in that environment for that period of time. So it is not just about installation. It's not just about going to just give me 3 coat system. It is more of conscious decision. It's not something we should do in a rush or do because we've been doing it. We have to put all necessary parameters into check and confirm that we are selecting based on the information we have concerning the system. Then if you can't control the environment, you can't guarantee the coating performance. So it's still a human thing. The coating will not decide for itself how it's going to behave. You do the necessary things and the coatings will behave accordingly. Then the next one is, this is just an addition to the slides. Um, advanced composite repairs. Now, yes, we have coatings that are engineered to do certain things, different function in different environment, but there is always room for improvement, new innovations here and there. So, and that is where we come. That's what brings us to advanced composite repair. So in many real world applications, especially repairs, we rely on engineered composite systems like those from Belzoni products that my company it's not realistic for you to paint to coat um, the the face of those flanges. Are you supposed to uncouple the flange because you want to coat in that flange? So and that is where advanced composite repair material has come to actually augment, not say augment or support or supplement. Yeah, that's the word. Supplement areas that coatings cannot actually do, maybe due to limited access to those areas. So we should always, I'll try to also explore advanced composite repair materials where coatings cannot perform or where coatings for one reason or the other. Because if you look at most of these composite repair materials, you will discover that they are not just coatings. They have been built in such a way that they do or they make up for areas that coatings cannot actually do. So we still call them protective coatings, but then they are more advanced. They are more how do I put it? I don't know the best word to use, but it's more or less like you are doing some stoichiometry, you are doing some chemistry to ensure that you are solving a particular problem on the field. And this is, for instance, flange encapsulation. Who would have thought that I'm going to coat this flange and still be able to peel it and close it back from time to time? You understand? So these are innovations that has come from coating industry to make up for areas that ordinary coatings cannot do. And I want us to also look towards that direction from time to time. Then, in conclusion, protective coatings do not fail by chance. No way. Oh, it happened by mistake. I don't even know how it happened. It's not like you don't know how it happened. It's just that you didn't put in concentration where you should actually put your concentration. You do put your energy in the right places, and those places are the foundation, the fundamental, starting from your decision to get a coating product. So protective coatings do not fail by chance, they fail by design or execution, whichever way. This is that you have already from your design, seeing the right monitoring. When we get selection, preparation, and application right, we don't just protect assets, we prevent failure. When we get selection, preparation, and application right, always know that you're not just protecting the asset, but we are also preventing failure. We are keeping our integrity intact, and we are also growing our professional presence. And that brings me to the end of this session. I hope you learned one or two things, and I hope it was insightful. I'll be glad to take your questions now. Thank you very much. So over to you, Tim. Let me know if you have any question you'd like me to address or
Yeah,
anything you
so
emphasize on.
yeah, thanks, Enoy, for that very insightful presentation. I'll just apologize again because in the middle of the presentation we had experienced a couple of technical glitches. So sorry about that. So on the chat box, we have one question and a few other comments that we can reflect on. So the first question on the chat box is, what is the acceptance limit of the soluble salt in marine environments and industrial environments?
Okay, so this question is quite the acceptance limit of soluble salts in marine environments. I would always say that these informations are usually provided on technical data sheets. The level of salt contamination that a coating can actually withstand on work effectively on are usually provided. So you may need to, or you may want to find out what the products can actually accept, what the products can actually withstand in terms of salt contamination. So I would leave that question. So it actually varies, but I know it's around 3 ppm or so, but I know it is not for all products. So you may want to find out what level of salt contamination can that product actually withstand. And that information mostly is usually being provided on the technical data sheet, or you also ask the manufacturers of this product to tell you, okay, this is the situation we are in right now. At what limits can I actually go ahead to apply my coating? And I'm sure every coating manufacturer will be glad to let you know how to go about that. Thank you.
All right. So there's some other comments. There was one around a general observation in terms of product description for corrosion protection. The terminology is coating, and for aesthetic purposes, the terminology is painting. So just your reaction on this comment. Like,
Okay, so this is true, but then for aesthetics, I think this is just true. I don't know if they can actually say that better. Yes, painting. Okay, you see artists trying to put one color or the other, they are painting. Even for her concrete walls, I also know that yes, even though we say we are painting the wall, a lot of things should also be put in place. And sometimes you're not just painting because you want your house to look beautiful, you want it to have that gray white color that we see in most places, sometimes you're also protecting the concrete that is beneath it. So yes, painting for aesthetics, perfect. But then in some cases you may want to say, okay, you're also coating your walls. Why? Because you are not just painting because you want to beautify it. You are actually painting or coating because you are protecting the asset. You know, when we talk about materials protection, we're not just talking about steel, even though steel is mostly or commonly or the most common talked about material. And that's because, a lot of funds, a lot of investments have been put into place compared to the regular bricks and cement. But then when we talk about materials protection, we're talking about both metals, we're talking about concrete, we're also talking about rubbers. Let me add that. I know we don't talk about that enough, but then, and I think that is just the best way to describe it. If you're talking about corrosion protection, and yes, corrosion do not just happen on steels only. You have materials degradation, and that is their home, that materials degradation for other products that are not metals. And all of those things are also would I call it a kind of corrosion? I know corrosion is strictly associated with metals, but then other substrates, metal, or other substrates like concrete also corrode in its own way. Even though we don't call it corrosion, we call it materials degradation. So, right, coatings for protection, painting for beautification. So I think that answers that. Thank you.
All right, thanks. Thanks for that.
Yeah.
So we have another one from Michael Davis, and his question is diamond wrap an example of advanced composite wrap? If yes, are there other examples of such aside diamond wrap?
Okay, so this question looks like a brand question. Sincerely, I don't even know diamond wrap, but I'm aware of advanced composite repair. So for the fact that I don't know diamond wrap and I know advanced composite repair, it just gives you the answer. Diamond wrap may be an example, maybe not. I'm not sure. I don't know about that. But when it comes to advanced composite repair materials, there are so many, but like I said, I represent a brand here in Nigeria with the company I work, and that is Belzona. Belzona is an advanced composite repair product that does all sort of things, not just coatings now, but other polymeric products. Like these polymeric products are designed in such a way that it does beyond what coatings can do. Actually, like you have products that can, just like I showed you in the flange encapsulation session, you have products that can use to protect your flanges for moisture ingress. And it's such was designed in such a way that from time to time you can actually open this encapsulation to confirm that, or if you need to probably open these valves, you can actually confirm and close it back. So aside that, we also have composite repair material that you can use to bond two plates. They are not just coating, though they are corrosion protection materials, but they have been designed in such a way that you don't need to weld. I get plate one, plate two, and I'm bonding them together with an advanced composite repair material, especially in areas where welding is not feasible. So there are a lot of them. And one example I am giving to you now is one that I represent here in the country and the one I can boldly talk about because I have a good knowledge of the various products that it does. Thank you.
All right. Questions keep pouring in. We have a lot of questions in the chat box. So we have another one. So this question says, do you know any paint manufacturer whose product are certified for application over laser ablated surface in oil and gas offshore? I mean, any example of paint application in oil and gas sector over laser ablated surfaces?
Okay. Do I know? Even if I know, I'm sorry, I won't be able to tell you because I also represent a brand that also does similar things. You understand? So, whether I know of any paint manufacturer whose product are certified over, so over laser ablated surface, I may need to confirm that information. But for now, I wouldn't say I know of any, or I would want to recommend any to you. Thank you.
All right. So this one is from Juan Carlos Rico, familiar name. So Carlos is asking, do you have any type of experience with HVHT metallic coating application?
Myself, you want me to come and apply HVHT? No, I don't have that experience. Thank you.
All right. Thanks. So we have another question again from Gabriel. So Gabriel is asking, what's your opinion on schedule when the clients hurry up the contractor to complete the job?
See, this, you see this part? I don't know how to say it. I think at one point or the other, we all have faced this challenge. Client wants you to finish up a job that would ordinarily take 7 days in 3 days. We know that, but see, I think we need to actually put in a different approach to meeting up with clients' expectation. That does not mean you should waste your time when you shouldn't be wasting time. You should be looking for compressor when compressor should already be on the field, with your blast men waiting. If they hurry you, let them sign a liability documents to agree with you that if this thing fails because you are allowing me to quote a system that should be overquoted after 24 hours, you tell me to quote it in after 3 hours, let me not be blamed for the repercussion. I think we should do better with documentation. If you want me to go against standard practice, you should be able to agree that you won't hold me responsible or spoil my brand's name because I did what you want me to do. So I think that conversation can be held amicably. A lot of, in fact, they may take 3 months. I have this experience. It may take them at least 3 months to decide whether they want to do that project. But when it comes to application, something that would ordinarily take 7 days, maybe when you check the surface preparation period, when you check the time that you need to apply the coat, maybe it's a three coating system that require you to allow the products to cure for like 24 hours before another coat. When it comes to execution of that job, they want you to do it in 3 days. A job that took them over 3 months to decide whether or not they want to do it. So in this case, I think we should clear our head, still stand your ground, do them a written document or a written mail to tell them this would have original. And before you do that, be sure that the fault is not in your hand. You did not waste unnecessary time. And when the customer tell you hurry, hurry, it is easy for you to compromise because you've also defaulted in your own execution plan. So please, let's be more professional with the way we handle clients trying to hurry us to finish up a project that originally shouldn't finish within those short timeline. Let them be able to sign the document. I think that will help us solve that problem better. Thank you.
All right. So another question again from Gabriel. Can you please clarify what you mean by epoxy not good for UV? Is paint not an epoxy? My bad. This is coming from a non-coating person. I have basic knowledge.
Okay, Gabriel, thank you for this question. So when we say a pause is not good for UV, you may want to take your time to actually study what the pause system is. Yes, they are very excellent corrosion resistant products. They are durable. They are very what's it called? They're very flexible. When I mean flexible, they are very compatible with other top coats. But then it has a downside, and that downside is that it tends to choke on exposure to UV. So what it means is that you can do an epoxy based primer for those who still do three coat system. You can do an epoxy based primer. Perfect. Your system is protected. You can do an epoxy based intermediate coat. Oh, you have reinforced the system and you are using an epoxy based finish or top coat. See, your system will be protected, but then you're likely to see dull surface in a very short time, especially if you're exposing the system to sunlight. So epoxies are not good for UV light. So if you want to solve that problem, you can use an epoxy based product directly on the steel, but protect the epoxy with a polyurethane-based product because those ones are more resistant to UV than epoxy we do. And I hope I've been able to answer that question, our non-coating person. Thank you.
All right, so thanks. I think we have a lot of questions in the chat box, and in the interest of time, this session was planned for 1 hour. So I don't intend to take even 1 minute from anybody on the call. We have also an additional session again tomorrow. Remember that this is day one of the 3 days series of this World Corrosion Day. So we have another presentation tomorrow, and that presentation will be talking about corrosion under insulation. This topic is one of the topics that is very dear to my heart. So there's one question I see on the chat box from one asking if there will be an attendance certificate issued. What I know is that we'll get PDHs for this webinar, but I can check back again to confirm if there's an attendance certificate, and that will be shared to everybody. Now, for the additional questions that we have that are yet to be answered, we'll mail them to Noye, and she would take time to respond to those questions. And we have those answers shared with the respective persons who are interested in having some more insight to the questions that they asked. So, on that note, I want to thank you, Noye, so much for spending our time to educate us on protective coating. Noye is one of our AMPP ambassadors, and she does very well with making herself available for AMPP related events. And I also would like to thank everybody on this call for also making our time to join and listen into these conversations. We'll have a follow-up conversations tomorrow on CUI. And on that note, I would like to say everybody have a good evening.